we will calculate or derive the relation for the kinetic energy of a particle accelerated by a potential difference, or you can say kinetic energy of a charged particle in an electric field. So you know okay, basically the kinetic energy or any energy is amount of work done. So in this case, work done we can calculate by force into displacement. Now force in this case for electric field will be F is Q into E, where Q is amount of charge, E is electric field. The acceleration produced by this force will be F upon m. We can say QE upon m. Now say the particle starts from rest, so velocity gained by the particle will be V square is 2as, or substitute the value of acceleration, so and value we get QE upon m into S. So from this formula we get the value of V square, and then kinetic energy is half mv square, that value is Q into V. So we can say the kinetic energy of a charged particle in an electric field is given by Q into V, where Q is amount of charge and V is the potential difference by which the charged particle is accelerated. Now here you have to keep in mind that this formula will be used, means this Q into V will be used in a number of chapters, like for example in this electrostatics. Then you will use the same relation in atoms and nuclei, magnetism, and at times in some other topics of EMI and AC at times. So say for example here we are calculating a alpha particle is there and a proton is there, and they are accelerated by the same potential difference. Then find the ratio of their velocities and momentum. If this sort of question is given, then you know the kinetic energy of the particle is Q into V. The half mv square is Q into V, so we get the formula of V square, that is QV upon m. So now we have to keep in mind that they can give you आपको 3 pair of particles. It can be alpha particle, proton or deuteron. So you have to keep in mind that if we take the mass of proton as mp and charge of proton as qp, then mass of alpha particle is 4 times the mass of proton because it is 2he4, and deuteron is 2 times the mass of proton. Charge of alpha particle is 2 times the charge of proton, whereas charge of deuteron is same as the charge of proton. So here we can substitute the values and we get the value of velocity of alpha particle and velocity of proton ka square, and that way we calculate the value. So we get V alpha upon Vp is 1 upon under root 2. Second part is saying a ratio of momentum. So you know momentum is mass into velocity. So again substitute the values. P alpha upon P of proton will be M alpha V alpha upon MP Vp. And again substitute the values of means relation of mass of alpha particle in terms of proton, and velocity you have got in the first part, so we get the ratio. Now next thing we are taking is equipotential surfaces. Equipotential surfaces are basically, you can say, the surfaces where the potential is same throughout. So you know one thing, if where the potential is same throughout, now kinetic energy is given by Q into V, where we are taking V is potential difference. It means what? And kinetic energy is also equals to the work done. So we can say since V is 0 for equipotential surface, so work done is 0. So we can say the first property is all the points lying on the equipotential surface are at the same potential. It is evident from the definition also. Second, if we take a charge from one point to another on an equipotential surface, then work done is 0 because potential difference between any 2 points is 0. Third, you have done the relation ki E is dV by dr magnitude wise. So we say if the equipotential surfaces are very closely packed, then at that point the electric field will be stronger and vice versa. Last, you have done ki electric field lines are always normal to equipotential surface. This we have explained just in the previous video. So now you can say ki if we have to, next type of question can be if we have to draw the equipotential surfaces for a point charge. You know the formula value is 1 upon 4 pi epsilon naught Q upon R. It is not a direct relation. Say for example, if you are having the potential difference of 10 volt we are taking. Means between any two consecutive surfaces, the potential difference is 10 volt. So in that case, in the beginning, if you take the distance 1 meter, then you take it 2 meter, then this becomes half. But if you keep on increasing the distance, so say for example, we move at the value R is 50 meter. Then to make it the half value of that, we have to move to 100 meter. So that's why we say that when we draw the equipotential surfaces for a point charge, then they are not equidistant from each other. In the beginning, the distance between two surfaces is smaller and it will keep on increasing. Means if we draw the other surfaces, it will come like this. Means distance will keep on increasing. Next thing is you are having two equal and two equal charges separated by a small distance. So we have to check at what point electric field is strong and at what point the electric field is weak. Now in between these, if you place any test charge, then these two will repel. So we can say electric field will be weaker. If you are having point on this side, then both the charges will repel. So at this point, electric field will be there in the same direction due to these two charges. So on this side and this side, you can say the electric field is stronger. In between, the electric field is weak. So in beginning, you can say if we draw the near the charge, then this field will dominate. So for first or second surface, we draw the perfect circles here also and here also. But after that, these two charges will start affecting each other. So because now in between the field is weaker, so we draw the equipotential surfaces this for which the distance is increasing, and on this side the distance is decreasing, because we have to show the surfaces closer to each other in a region where the electric field is strong. Same way, if we are having the two charges which are equal and opposite, then again the same rule, you put any test charge in between, this one will repel and this one will attract. The electric field is there in the same direction. For this point, the electric field is there in opposite direction. This side also the electric field is there in the opposite direction. So in between, the electric equipotential surfaces are closer to each other. Here they are far apart, and in the beginning, means just closer to the point, they are perfect circles. And after that, we have to show the distortion. Now, one last question, say we are having a test, any charge kept at the center of a rectangle or the square, and say we move any other charge, which is like, for example, a test charge from A to B, means diagonally opposite corners. Then diagonally opposite corner are at the same distance from the charge. So we can say in that case, A and B are at the same potential. So work done in taking the charge from A to B, any other charge, then this Q will be 0. Now next, we will discuss in the next video.